Hello everyone, it is November 29th, 2023, and this is the libhal bi-weekly meeting. Alright, for the agenda today, we're going to go over the libhal CCI breakage and how we resolved it. We're going to change, I have a bit of a change of heart when it comes to destructors, with drivers specifically. Eliminating complex profiles, I'll be going over what I'm doing in order to remove a lot of the code that's in there. I'll also show you what's currently in there and what I'm trying to do to eliminate a lot of that extra stuff. And then we'll go over the pathways to 3.0, which is us introducing exceptions to libhal. All right, so the CCI breakage, due to this PR, it's called libhal add version 2.00, add package type. Couple problems with this. So actually, there's a third problem. I just realized this, but number one, when this person made the upgrade, they were told by the Conan folk to move from boost leaf to boost because boost leaf was deprecated. And I was not alerted that someone was updating libhal. I would have been able to tell them, hey, you can't do that because X, Y, and Z reasons. And I have not tried to test it with boost. I think they assumed that it should just work, but that's not really how this goes. Another thing is that the person was also missing one of the other dependencies, and I was so caught up trying to just get libhal to have boost leaf in it that I forgot to also check to see if there's any other dependencies that were missing. So basically, because Conan Center Conan defaults to the Conan Center first for packages, all of this continuous integration tools basically said that we were failing everywhere, and you really couldn't build anything that needed libhal if you didn't already have it cached on your device. It'll prefer the cache over what's on online. Now, this took about 3 things to resolve. The first one is just correcting 2.01 dependency, which is actually what this thing was. Adding myself as a reviewer so that if the libhal recipe ever gets updated, I can go in there and it'll alert me to tell me, hey, this is currently a PR. So I can go in there and kind of stop things or at least communicate a bit. And then also add missing requirement, which is the TL function ref, which I didn't realize until the thing was pulled in and I was still having CI issues. Now, one of the things that I also came out of this was that after all this extra work, one of the members of Conan was trying to make boost work without needing to basically make it work for embedded. And he tried, and after a while he realized like there are so many different options you have to turn off in boost to disable certain features when using Conan. And even with as many of the features turned off as possible, there were still certain requirements that were kind of entangled in there that made using it on bare metal systems nearly impossible. And there's quite a few things that goes into this. I'll talk about this a little bit later, but for the most part, if you ever have to build a binary, Conan currently doesn't support embedded systems very well. If anything, we are introducing embedded systems to Conan because no one else has really decided to do this yet. So this is new ground. That's why a lot of stuff doesn't already exist and why we're hitting these issues. It's because we are the first ones to really go into the space and provide context for why certain things need to be certain ways. So that's the CCI breakage. It should be working now. You should be able to use 2.01 and 2.02. I don't recommend using them. Just go with 2.03. There's no difference between 2.02 and 2.03, so just go for it. All right, so talked to a couple of my friends. They had their opinions about drivers being able to have destructors. In general, I think that most drivers should never have the destructors run. I think that in most cases when you're developing something, the driver should exist for the entire runtime of the program. But there are cases where you may want to do something that's hot pluggable, somewhere you can take something out and put it back in. Let's say we had a set of IMUs and we were able to control what type of address they can have. And we want to have some system that every so often pulls the I2C bus and checks to see if there's anything there. And if there is, register that particular I2C device and add it to our list. Now, you could do this with variants. You would still want to be able to destroy the things that you created. You can't really reconstruct on top. You can reconstruct on something that hasn't been destroyed yet, But there might be some utility to having an instructor, even if it's not like talking to the device, because you can't. If something goes wrong with you talking to the device and you've lost communication, trying to talk in your instructor is a bad idea. No, usually you'll do any cleanup that you need to do, unlock any mutexes you may need. More importantly, or you're using, or more importantly, if you registered yourself in any certain way, you could unregister yourself in the instructor. Basically, there's utility in using instructors. I had the idea with the entity stuff to try to get rid of that. That would eliminate some of the memory safety issues with accessing stack after it's been freed. But really, I think the keyword static is easy enough for most people to use. And you got to know what things you're using and what things need to be static allocated, which things do not need to be static allocated. So that's it. Treasures are back. That PR for entity I'm going to push, then immediately close and then delete the branch for it. So that's that. All right, so I'm going to show you what the profiles look like currently. But the main thing here is that I'm going to be eliminating the complex profiles. I realized that it was a bad way to try to manage selecting which thing. I should put this. So we will still have profiles to say I am building for LPC 4078. That makes having that profile is really powerful and really useful. So we'll still have that there. The difference is that the stuff that's going to be inside of it's going to be a lot smaller. Now, we haven't hit any problems with it yet, but effectively trying to move or trying to change that file breaks things backwards. And because it's such a fragile setup, it's in our best interest to try to go away from it. Let me show you what I'm talking about. So I'm going to go here. I'm going to go to LPC has the best, in my opinion, profiles. Actually, let's just go over to libhal LPC. I'm just going to build libhal LPC. So Conan, create. I'm going to do it for a 78. We're going to look at the profile up here. And what we're going to do is look at all this extra stuff. We have architectures equals to thumb v7. We have flow ABI is hard. We have the FPU is set to auto and the processor set to Cortex M4. And the build type is this, and got other information. Now, this is all information that we need. And actually, I would say that this is all information that we would ever need. We have options set for the platform. Now, I know that a lot of people don't understand how options work because it's another interesting area in Conan. It allows you to enable and disable certain features in a library. So if a particular feature uses IO streams and you don't want to support that, Boost does this, then you can disable IO streams and it'll disable it globally for the entire project. So you can pick and choose what parts and pieces of a particular library you want to use. One of the kind of global options is called the platform. And the platform can tell a demo or a library or a set of libraries how to configure themselves to best support that particular platform if they have something that's specific for that platform. Again, title a little bit later. Tool requires, this basically forces the compiler to be ARM GNU toolchain. We have configurations that basically set certain flags. Now the thing is, I did all of the mappings between the architecture and like basically architecture stuff to flags through these configurations. They're just entries in a file. It looks like this when you take a look at it. Let's zoom in a little bit. Thumb v7. So you see a lot of this. Note that profiles for Conan are Jinja templates, so you're actually able to update them and modify them by inheriting or importing them. LPC has an example of this where you can see that we've Conan here, and then we have LPC 40, which is more Jinja templating stuff. And we go here, and you can see that we just have include the Cortex M4 file, set the platform to this, and then include LPC 40. This includes that, and then so on and so forth. So there's a lot in here. There is an exceptional amount of extra stuff that's added into the C flags. And here's the problem. And this is what I kind of dealt with when it came to trying to get Boost to work. I realized that what would make Boost compile at least to get the backend stuff, like the test packages working. Whenever you build a package, you also have a test package to ensure that you can actually build it for the platform that you specified. And in some cases, you can also try to run it if it's runnable on your machine. In this case, since we're using cross building, we never run the test packages. We just need to prove that they do actually build. Now, here's the thing. If you try to build any old project without these flags here, what's going to happen, and you try to use the ARM GNU toolchain, is that it'll fail. It'll fail because it'll say that standard out doesn't exist. It'll say that like file or read or write or things file IO type stuff doesn't exist. This has to do with the fact that you have to specify which standard library you want. And by default, for almost all systems in general, when you ask to build something for bare metal or for freestanding, in other words for that, or just embedded systems, you would normally assume that you don't have access to any of those facilities and you either have to write your own functions to implement those portions of the C library, or you write your own APIs and use your own thing. But this all could work if we simply use the specification. Where is it? Gnosis. Basically, this basically puts a whole bunch of stubs for all those other APIs and will give you a warning saying these aren't defined, so you shouldn't run this thing. But yeah. Also, I think a lot of packages don't have checks for cross building, which means that if they are cross, actually no, I take that back. I think they're supposed to all have that, so never mind, I take that back. So yeah. There's a lot of garbage in here. The cool thing is that the majority of all of this can be moved into, well, first things first, I'm going to simplify the architecture. I realized that we could just do things like Cortex M4 or Cortex M4F to represent that we're using Cortex M4 with hard floating point. Basically, just having a name is far more powerful and far simpler to work with. I bring this up because when I talked to the creator of Conan, Diego, I showed him what I had, and I might have said this before, but he basically said, yeah, no, this is awful. Please don't do this. This is too many options, and our settings YAML file will become gigantic. I understand that you may have all these very specific minor things, but if you could find a best common denominator between everything, that would be best. Because right now we're trying to manage the complexity of how many different things we could try to target. And what we really need are for people to try to make sure that they don't try to target their particular set of things, but try to target a wider audience. And I think the widest we need to target is simply the Cortex name, and then maybe a designator for hard floating point support. And I think certain things will just automatically be enabled, like SIMD control. I don't think there's anyone who really wants to disable SIMD on their machine. It doesn't really benefit you much. I don't think there's like any power savings to get from that. Whereas hard float and soft float, technically, there's some reasons why you may want to disable it in some cases. That's all to say that a lot of stuff can actually just be condensed into one, added into the settings file, which currently looks like this. You don't have to understand the insides, but basically he saw this. He was like, no, make it just arc and just give it the list of all of these guys. That's all. If you can just do that, then we'd be happy. So that's what we're going to do. So we're going to start reducing the complexity. Oh my goodness, where's Chrome? Okay, so here. Okay. Profiles will still be there, but all they'll do is set the option platform, and they'll set the architecture to one of these architectures. And in the future, we'll have some for RISC-V microcontrollers. We'll have some for, why am I blanking right now? RISC-V is one of them. I feel like I had other options, but basically we'll have arcs for other things. And that's about it. The GNU toolchain, when it sees the platform, it'll automatically impart those compiler flags into the compiler, basically just specifying whether or not the hard float is turned on and whether or not what's the other word I'm looking for? Hard float is enabled, and whether or not what Cortex it's set to. It'll also introduce another option called newlib. Now, the option will not change what I will call what Conan calls the package ID. I don't want the option of newlib to make it look like there are two separate ARM GNU toolchain binaries. The options are technically looked at as different packages. So if you change an option for different features, it's a different package. Now, we're not going to have that affect the package ID of this. The main idea is that if you don't specify your newlib, it defaults to no sys. It just assumes that you don't want anything. That's a that's one option. I was thinking also doing nano and gnosis. Basically, gnosis will the way that it works is that depending on the order, the last one is I guess like the highest priority. So if you say I want Gnosis, meaning that like all your C library APIs for different things basically get implemented through Gnosis for things that like don't exist, like file systems and all that, and like a real time clock or something like that. In those cases, um, uh, Gnosis will fill up all the gaps of things that aren't really filled. If you put in Nano, it'll fill up the rest, and if you put in Pico, it'll fill up whatever it could override. Um, So the idea is that you can choose which C standard library you would like. You can start with newlib, which I recommend no one using unless you want to just experiment with it. Newlib is the default that you would find on your laptop. So you pretty much get access to everything, but your binary will probably blow up to at least 120 kilobytes. Use Gnosis, and if you call any of those APIs, it's either undefined behavior or I think it's undefined behavior. I think it has stubs that just return immediately or something like that. So it doesn't really do anything. But whether or not that like imparts problems on your code is, that depends on you. Nano will implement things as well as it can, but it will yell at you if certain things aren't implemented. It actually basically gives you, whenever you call any API, here are a list of things that aren't defined. You need to define these in order for me to work appropriately. Like, for example, if you call malloc, you need to define SBRK, which is it's called set break. And it's what chunks and grabs additional memory from wherever you're getting your memory from and gives it to malloc to manage. Pico libc implements all that stuff for you, and you don't really need to implement all that stuff really for yourself. And if you just use it, it just kind of works. The only things that don't work, like malloc automatically just works with Pico libc. There's nothing you have to do extra on top of that. So long as you define the appropriate symbols in your linker script. Where was I going with that? Yeah. So Pico libc makes a lot of things work. The only things that it does not make work are things like file system stuff or time. It doesn't have any way to derive that. So you'll be allowed just like that. I'm hoping that when I test this out, ARM GNU toolchain will be the one that kind of originates this option, and it can be overridden whenever you include one of these other libraries. These ones are going to be defaults that are going to be available, but Pico libc actually has the ability to override that option for you during the build, such that the final binary will use the Pico libc. This works because Pico libc just provides the binaries that hook into all those APIs, so we can swap them out as much as we like. Cool fun fact, I didn't write this part down inside the slide deck, but the same thing is going to happen with exception handling. You'll be able to choose how you want your exception handling to operate. The default will just be you use the default. Another option is going to be you want to use fast exception unwinding, or I'm sorry, fast exception search, which if I add the feature into GCC, where you can actually split up your code into trivial and non-trivial blocks, then you could, normally that wouldn't actually help you. Normally what that would just do is simply tell the system would just search anyway. But once you have code that knows how to handle that, it can improve your exception speed. And there's other things that we can do in order to improve things. And yeah. Oh, and also Pico libc is going to be one of those libraries that I think everyone should just automatically use. It'll be the thing that we advocate everyone use with their packages. So every package will probably, that uses ARM, or actually anything really, will almost always have a toolchain they select, as well as which newlib version they want to use. And I'll always recommend they use Pico libc. So yes, that's that. And the last bit here that I want to talk about is pathways to 3.0. So in order to get 3.0 ready, basically all of the profile stuff has to happen. The reason why eliminating all the profile stuff is important is that I can keep it intact for old code so it's backwards compatible. But the hope is that we almost eliminate needing to use them to the point where you won't really need to build them out very much. You'll simply just need to, make your own old profiles, very simple, small profiles, and be good to go, which is what you're intended to do. I provided them thinking that I was going to be smart. Turned out that I put myself in a bad position because I didn't realize how bad this could be. But yeah, so first things first, the actual profiles contain no exceptions. Yeah, no exceptions. I'd have to change this. That's why I can't modify these guys. I could make another version for it, or make like a different tag for the different ones. but it's weird because currently everything points to main, so I couldn't make a tab. I could make a tab for an old one or a branch, but as you can tell, it gets kind of complicated. And this is kind of a gross way to manage this when I would prefer if the Conan version control system could handle this, which I can get to work using uh, the Conan files. Next thing is to create the picolib library. It uses Meson and Ninja, which I thought would be simple enough. But the problem is, well, actually, I basically they have scripts that help you do all this stuff, and I don't know if I should go with the scripts or if I should run Meson directly. And I also don't know how to use Meson very well in Conan, so I'm trying to figure all that stuff out. Hopefully, I can get it to just work naturally with Meson in Conan. Because if I get that to work, then anytime they add a new version, we just have to like grab the source file and then build that way, rather than being tied to specific build scripts that they produce. Because I don't know if there's anything too strongly, what's what I'm looking for, consistent with those. And then last thing is transition the following and verify that the demos work correctly. libhal ESP8266 and libhal RMD. Now I have done testing with I2C, specifically the probe API, because the whole idea of probe is to actually use exceptions in a control flow manner. It's one of the few situations where it makes sense. Let me show you what it looks like. It should be in not soft util. I2C probe should be at the bottom. Second to bottom. Where's probe? Oh, this is the old one. Let me go back to the. Okay. Let's do, let's get this thing out back to main. Can pull it, and then I'll go to exceptions. Okay. So we can see here at probe, we do a try, we do a transaction, and then if we catch a error code, we check to see if it is a no such device or address. We know that's the only thing that should really be popping out of this guy, unless something about the implementation of I2C sends out other bits of information, some other type of exception, in which case, like an array out of bounds type thing, in which case we just want to rethrow that. We want to just let that pass through. Although in this case, this is if you catch a error code and it's not one of these, it might be something else, just rethrow it. Maybe something else went wrong. And then we have a device acknowledged. So we just, if we catch it and it's one of these, we do device acknowledge, return that. So it's used for control flow. You honestly shouldn't be using probe that often. You should only really be using it when you need to. So it's a reasonable cost, not too bad. I wanted to verify that this could work because when I tried testing this, it would work for like 3 or 4 probes and mysteriously just break. And it had to do with, I don't know if I talked about this last time. How much time do I have? Oh, we got time. So I'm just going to talk about some of the silliness with CXA. This is a very much a C library thing, where the data that you're given is assumed to be cleared. I don't always know if it's made clear anywhere else. NewLib makes it clear that you have to clear out your BSS section, but if you go over to this area over here, this is bad. This would not work very well. It kind of works here. I forget why, but in any other situation where, like, I guess the functions aren't kind of similar, this would be a problem. But basically what happens is you actually need to, like, clear out some of the actual, like, data that you free. Otherwise, when the exception handling mechanism uses the extra memory that you gave it to figure out what it needs to do, it will assume that it's in the previous state of the last exception, and you will have problems. So, So I had to test that out. This was a good example. This is a good stress test to make sure the exceptions were working appropriately. That's not it. Here we are. So I want to do the same thing with libhal ESP and RMD. I want to make sure that they work as intended. I want to make sure that the CAN libraries and CAN router can allow exceptions through and not cause any particular huge problems. And then once we have that done, I think that'll be a good point to switch over to 3.0. I won't create the improved exception handling library yet. I will be working on that, but that doesn't require us to move to exceptions. We can move exceptions as the default for now. I think all use cases where it's the Astraeus or the robotics team or any other projects that we're considering doing, all of them can probably, not probably, definitely can handle the number of cycles that we're going to spend on exceptions. I think getting them smaller is more helpful for situations where you really need that performance. And that's pretty much it.